Hello and welcome to the Daily Space for today, Friday, June 12th, 2020. I am your host, Dr. Pamela Gay, and I am here to put science in your brain. Today, we found our inboxes bursting with news of all kinds. So today is going to be a bit more crammed together than normal. Our first story for the day is all about the sun. And this nearest star to Earth both warms our days and periodically kills our spacecraft with its outbursts. While clearly it is nice to be warm, we like our spacecraft, and figuring out how to better live with our sun's weather is the goal of space weather researchers. For 200 years, folks have been finding ways to study the surface of our sun and its changing star spots. And for nearly 100 years, folks have been finding ways to also study the massive solar flare and coronal mass ejections that we see as vibrant aurora. On their own, sunspots are harmless, but those other two events, flares and mass ejections, they can include enough high-energy particles to affect our high-tech infrastructure. In the past, we've seen the power grid in parts of Canada go down as these particles excited our planet's magnetic field, which in turn drove charge through the power lines until they collapsed. We've seen satellites get their electronics fried, and we've seen historical data that indicates the flares we've seen in recent decades are mild compared to some in the past. So, how do we predict when these massive flares and ejections are coming? Well, according to new work from scientists at Warwick University, exact predictions remain impossible. The sun can be dangerous and produce dangerous weather events at any time. But we now know that the greatest activity is likely to occur when the sun is experiencing what is called solar maxima. Over an 11-year cycle, the sun's magnetic field can invert, and as the field goes from quietly aligned with one of the sun's rotational axes to quietly aligned with the other axes, it will, get not so quiet, and we'll end up going from having virtually no spots to being covered in sunspots when that magnetic field is most tangled before going back to having minimal spots. That maximum magnetic field chaos and maximum sunspot period is called solar max, and it is then that we need to worry. By combining 200 years of sunspot data with 150 years of geologic and other records of geomagnetic storms triggered by the sun, this team, led by Sandra Chapman, showed that 1 to 3% of activity occurs during minimum, and the sun's activity ramps up. And as the sun's activity ramps up, so does the likelihood of bad solar weather. According to Chapman, the ability to estimate the risk of a future solar superstorm occurring is vital for space and ground-based technologies that are particularly sensitive to space weather, such as satellites, communication systems, power distribution, and aviation. If you have system sensitivity to space weather, you need to know how likely a big event is, and it is useful to know when we are in a quiet period, as it allows maintenance and other activities that make systems temporarily more fragile. This is particularly relevant for future plans to put humans on the moon and send them to Mars. Currently, we don't have any artificial radiation protection for them. And our best hope will be to send people on those grand explorations when mostly the sun is quiet. Let's face it, the universe doesn't make it easy on us. It is filled with dangerous objects, including apparently our own sun, and is changing in ways that are incredibly hard to understand. One mystery that keeps getting harder and harder to explain is the rate of expansion of the universe. Since everything that is once occupied a single point and, now occupies an undefined and vast volume, we know expansion happened. We know it happened. But by using objects of known luminosity, we can measure the distance to galaxies in the near to middle distance of our universe, and then use Doppler shift measurements to get their velocity the same way a speed trap clocks your car's velocity. Using complex models and measurements can also get at the expansion rate by looking at various facets in the early universe, including cosmic microwave background radiation. Now, back when our measurements had large error bars, all the measurements of the early universe, the middle universe, the current universe, they were all consistent. But as our data has gotten better, the agreement between the expansion rate measured from things going on in the early universe and the rate measured from things going on today have fallen into disagreement. This could mean our ability to measure distances is wrong, or that our physics is wrong. I'm not going to lie, I've been hoping we'd find a measurement error that's easier to deal with. Today, however, a new paper in the Astrophysical Journal Letters by lead author Dom Preskey finds that measurements of the expansion rate that use masers as standard candles are consistent with measurements from supernovae and quasar geometry, but do not match the early universe measurements. This means our observations are good, and there is something wrong with our physics. This is terribly exciting. We have a new problem, and it's also kind of terrible because we have a new problem. This isn't to say our physics is completely wrong. That's always an option, but it doesn't have to be the only option. In all likelihood, we have some term missing or some assumption that is just wrong. And when we run the numbers someday corrected in some way we haven't figured out yet, it'll be okay. It's like forgetting to include the dog in the household budget. Things just don't work out as expected and everything falls a little short, and then you realize your mistake and everything is fine. There are lots of times in science that we find things need revised over time. Now, luckily, there are some times that we just get things right. The one place that so far has just been right is the case of relativity. We have confirmation that even under relativistic conditions, objects of different masses will still fall at the same rate under the same force of gravity. This is confirmation of an experiment we've done here on Earth where people drop things like a feather and a brick in a vacuum and both fall the same way. Astronauts have also done this on the moon. That experiment is hard but doable here on Earth. Testing things under relativistic conditions, however, required finding a triple star system of truly massive proportions. The system, PSR J0337 plus 1715, contains a neutron star and two white dwarf stars of two different masses. The 366 beat per second rotation of that neutron star, which is a pulsar, gets shifted by the gravitational pull of the two white dwarfs and allows direct measurement of how those white dwarfs are falling around the pulsar. After making a whole lot of measurements, it was clear both objects fall the exact same way, showing once again that Einstein got it right when he figured out relativity. Finally, we have a few news notes to share in rapid succession. Astronomers at Durham and Johns Hopkins universities have used the MESSENGER data to confirm the lifetime of free neutrons in space generated on or near the surface of Mercury. And these neutrons were then detected by the orbiting spacecraft. They've determined that this neutron lifetime is 13 minutes, give or take 130 seconds. And this measurement of the lifetime of a free neutron is consistent with measurements made here on Earth, where neutrons aren't so much free as they are trapped in containers where they can't interact with other particles. This measurement is also consistent with our standard model of particle physics. So yay! Filed under what would happen if you put a telescope at the edge of the solar system. The New Horizons team has obtained simultaneous observations from the Earth and New Horizons at the edge of the solar system and has gotten that data back to Earth, which can take a long time. And these images show with remarkable clarity the jump in position of nearby stars compared to the background objects. This is this star equivalent of holding up your thumb and blinking between your eyes and seeing your thumb move relative to the background. These measurements confirm what we've been able to see with Gaia and other telescopes, but at a new level of accuracy. We're still waiting to find out exactly what the accuracy is. This isn't published yet. The images were released, and these images were just taken. And in April, it took the data 6.5 hours to get to Earth. We don't know how long it took to get the entire data set back to Earth. Each bit took 6.5 hours, people. Imagine. Finally, in more news of little scopes done good, the SETI Institute, working in partnership with Unistellar, has published the confirmation of a planet orbiting Qatar 1 and has precisely measured the distance to asteroid 2000 UD52 using a network of amateur astronomers using telescopes an average person could pick up and carry. This is proof of concept and shows once again that backyard astronomy is part of how we understand our universe. And this work paves the way for folks to do more and more projects in the future. All right, that's it. That's all we have for today. Actually, we edited a lot. There were more stories we could have done, folks, but wow, no, that's what we have for today. So I'm now going to answer your questions, but before I do that, I would just like to say this episode was written by me, Dr. Pamela Gay. The web content will be produced by Beth Johnson. This episode will be engineered by Ali Pelfrey, and this project of CosmoQuest is part of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. We are all here thanks to the volunteer efforts and generous contributions of people like you. Your bits, your subs, your patronage at patreon.com allows us to pay our staff a fair wage. And we're actually hoping if we can increase our donations to start offering folks benefits. Toward that end, we're going to run a special event in July, a Cosmo Questicon, and that website for that project is going to go live the next few days along with ticket sales. Thank you, Embius, for the bits. I have a dog cam and I have dogs that recognize that noise. I also apparently have a roll of paper on the floor. Don't know what's up with that. Thank you, Astro Z. Thank you. Thank you. Thank you. We are planning a big event in July, basically an online con, including masquerade, gaming sessions, the whole 9 yards. Stay tuned. Tickets for general admission will be $20. There will be a special package at the $100 level, all sorts of cool things to get involved in. And all proceeds go to providing our staff with benefits. I would really like dental. I really would, not gonna lie. So our goal is space with benefits. Stay tuned for more information. All right. What questions do we have? I'm going to sneeze. Sorry. Sneezes happen. I don't know why you never see sneezes on like CNN or anything. And I apologize for the slack that was going on in the background. I couldn't figure out how to gracefully turn it off while talking. All right. Questions. Let's see what we've got. Open Cage says, what is the image angle here? I think you're referring to, I forgot to switch to actually show you the dogs. More bits coming. Hey, doggo. What's this? Do you want this? Go get it. I think you were referring to the New Horizons data when you asked that. Um, the image angle is not in the image release. It's whatever angle you get between these objects and the Earth and where New Horizons is. Like I said, the publication isn't out yet. They're just doing an image release right now. Stay tuned. We'll cover it more. Right now, it's just kind of cool. Hanny asks, could a field from the early universe have petered out like how dark energy started revealing itself? We have no idea. No idea, Hanny. Looking for more questions. So Hanny asks, how much warning would we get of an event? So this is referring to a coronal mass ejection or solar flare. This is why we have the Solar Dynamic Orbiter parked at a spot between the Earth and the Sun. Because the particles travel slower than the speed of light, we can first see the light from the coronal mass ejection, then measure the particles. That difference gives us the velocity of the particles. We can then warn the Earth. Generally, it is minutes to day-ish warning, but not more than that. We do know when there's like something brewing on the sun. We just don't know if it's going to release while pointed towards us or pointed off at a different angle. Rotating objects just make everything a little bit more complicated. Let's see, anything else up here? Adam, altogether, your 1 bit is fabulous. I shall throw 1 bit to a dog if he will come here. Come here, baby. Come here. Come here. He's like, no, I don't trust you. Okay. The dog got 1 bit for your 1 bit, and he liked it. We like it too. All right. Let's see what else is in here. Thank you, Aristro, for the 100 bits. Scrolling. Not seeing any other new questions. Just bits. Thank you. You guys are awesome. Thank you. And Hex, Gesundheit is a perfectly good thing to say. I'm amused. Let's see if thank you, Alara Sophia, for subbing for 13 months. Come here, guys. Hey, come over here. Come on. There we go. There we go. Hey, dog, you're missing out. Go over there. Malachi's like, wait, there's bits? Silly dog. Thank you, Alara Sophia. You've been with us for over a year. That's amazing. Hello, Ditsk. Hello. All right. So today is going to be a busy day. In an hour and a half, we are running Astronomy Cast. I need to eat and prep for the show and also record the podcast. Yes, we have a podcast of the Daily Space. Did you know that? The podcast is actually a highly engineered version of this. You guys essentially get the dress rehearsal. If you haven't checked it out, check it out. Please give us a sub and drop us a review. That is actually one of the best things you can possibly do to help us out. Just open iTunes, leave us a review there. Open Google Play, leave us a review there. I don't know if you can leave us a review on Spotify, but like favorite us or something. So wherever you go to get content, if you can leave us a review there, it'll help other people find our show. And the more people find us, well, the bigger and better our community. We hope. Currently, we have a pretty awesome community. So I'm not really sure how it'll get better, but bigger means, well, everything gets a little bit easier. So go check out our podcast. I'm going to go record our podcast. For now, though, let's see if there's anyone to raid. Come back in an hour and a half, though. And I'm open to rating suggestions. Currently, I'm not seeing any of the normal subjects for some reason, but I have to admit the rating feature. Oh, Bother's on. We're going to rate Oh Bother. Come back, please. Come back, please. So in 1.5 hours, we're going to have Astronomy Cast. For now, though, this has been The Daily Space. I am your host, Dr. Pamela Gay, and I wrote today's episode. Our web content will be produced by Beth Johnson, and our audio and video will be engineered by Ali Pelfrey. We are a product of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our universe and beyond. Go forth, be awesome. I'll see you soon. Bye-bye.